Lesson 3.4, Direct Variation. In this video, you will learn to write and graph direct variation equations and solve problems involving direct variation. In this chat section, the vocabulary is direct variation and constant of variation. Okay, so if we're looking at these, the constant of variation is the number that's in front of the x. So looking at this, in front of the x. If they say to name the constant of variation is going to be 2. And then it says then to find the slope of the line that passes through the pair of points. So we learned how to do slope in the last section. So this is x1 and y1 and x2 and y2. So if we're trying to find slope, slope is y2 minus y1 over x2 minus x1. So 2 minus 0 over 1 minus 0, and I get 2 over 1. And so my slope is 2. Okay, so I did those two things. For B, name the constant of variation for the equation. So again, the number in front of the x is our constant of variation. So our constant of variation is -4. And then it says to find the slope. So again, x1, y1, x2, y2. So slope is m equals y2 minus y1 over x2 minus x1. So y2 is -4 minus y1 is 0. x2 is 1 minus 0. I get -4 over 1. And -4 divided by 1 is -4. So what do you notice about the constant of variation and the slope from this problem and the one before? Both times they were equal. So if a function is directly related, we can say the constant of variation is the slope. They're the same thing. Okay, so if I want to graph this, also something else about direct variation always passes through the point 0, 0. Okay, so if I want to graph this, I know it goes through the point 0, 0. Okay, so remember, and if this is the slope, remember slope is rise over run. So how much it goes up over how much it goes left and right, up or down over left and right. So rise goes up and down, and run goes left and right. So I'm going to think of -3 over 2 as being, you can either think of it as -3 and 2, or you can think of it as 3 and -2. So the negative only goes to either the top or the bottom. It does not apply to both. -3 over 2 is not equal to -3 over -2. That's not true, so don't do that. Okay, so from here, if I want to go, if I'm using this one, that means it's going to go down because it's negative, and then forward because it's positive. So I can go down 3 and forward 2 points, and that brings me right there. Or if I wanted to do this one, because it's +3, it can go up 3 and go backwards 2 because it's negative on the bottom. So I can go up 3 and back 2. And if you notice, they both fall on the same line, so you can use either method. Okay, and you connect your dots and you draw your line. Okay, so we graphed it. So you just use the slope and the intercept, or the 0, 0 origin. Okay, so direct variation equations are of the form y equals kx, where k is not equal to 0. So the graph of y equals kx always passes through the origin. I mentioned that. So if it's this one, if k is positive, greater than 0, then the slope is positive. And the slope is negative if k is less than 0. So if k is negative, it's going to be a negative slope. So it's going to be decreasing as you go from left to right. Okay, so we want to be able to write and solve a direct variation equation. So we just said that direct variation equations look like y equals k times x, where k is the slope. Okay, so if I want to figure out what k is, I can use information they gave us. So if they said, suppose it varies directly, so we can use this equation because it says it varies directly, and y is 9 when x is -3. So I can put in 9 for y and -3 for x. So if I want to know what k is, I want to get rid of this -3. It's being multiplied, so I do the opposite and divide. So now I have 9 divided by -3 is -3, and that's k. So that if once I find k, I can say for any value, y equals -3 times x, and that is my direct variation equation. Okay, using that what we just found that the direct variation equation is y equals -3x. They want to know what is x going to be if y is 15. So I want to find x when y is 15. So I'm going to put in 15 for y and solve for x. So to get x by itself, I'm going to divide by -3, and I get -5 equals x. So x equals -5 when y equals 15. Okay, the Ramirez family is driving cross country on vacation. They drive 330 miles in 5.5 hours. Write a direct variation equation to find the distance driven for any number of hours. So direct variation equation, whenever you see that, you should be thinking y equals kx. Okay, so the number of miles depend on how many hours. So this we're going to think of as our x, and this we're going to think of as y. So x is the independent variable, and y is the dependent. So we're going to put in 330 equals 5.5x, and I can use this to solve for x. So to solve for x, I'm going to divide both sides by 5.5. So divide 5.5. They cancel here, and 330 divided by 5.5 is 60. So I get x equals 60. So the equation is going to be y equals 60x. Write a direct variation equation to find the distance. We can even call that distance equals 60 times t. So like time times the 60 gives you how far they'll go. So if I were to graph this, y equals 60x or d equals 60t. Again, because it's direct variation, that means it's going to start at the point 0, 0. I put the graph in here because it won't come out nicely if I try and draw it myself, but I'm going to show you how you would do it without it already being drawn. So you're going to start on your graph at 0, 0, and if it has a slope of 60, you can think of that as being the same thing as 60 over 1, because 60 divided by 1 is still 60. So that means it's going to go up 60 and forward 1. So from here, I'm going to go up to 60 and forward 1, and that brings me to that point right there. Once you have 2 points, you can draw a line through them, and you get the rest of that graph. Okay? Part C, you graph it. Part C says estimate how many hours it would take to drive 500 miles. So I'm going to go back to that graph that I have drawn here. Okay? I want to know how long it'll take to go 500 miles. So if this graph were to keep going like that, and I want to know how long it'll take to go 500 miles, I'm going to go over from 500 till I hit the graph and see what time that would be. So this is probably like 7, that might be about 8. So I would say it would take about 8 hours to drive that distance. Okay, and that is the end. I will scroll through and you guys can do the extra practice problems if you'd like.